Hey guys, welcome to the next Alkyne video. So in this video, I'm going to cover a couple of questions you guys may have seen in your workshop quiz that was due on Wednesday. Now I had to wait until after the deadline to be able to show some of these questions because well, we can't really show them beforehand. All right, so we're going to just go over some of these things. So the first question was, we react 2-butene with H2 over Lenoir's catalyst to give some sort of carbon chain with 4 hydrogens and 4 carbons, 8 hydrogens, and then we reacted with Br2. All right. So the first step is to draw a 2-butene. Now this is similar to when we name alkynes. Alkenes. So but means we have 4 carbons. The ine, Y-N-E, tells us we have an alkyne, which is a triple bond, and the 2 tells us what carbon the double bond starts at. The triple bond starts at. So we're going to draw 4 carbons, and it says 2, so that means your triple bond starts at carbon 2. So that's going to look like this. So let's the number of carbons: 1, 2, 3, 4. Okay? So that's going to be 2-butene. Now we're going to react with H2 over Lenoir's catalyst. So H2 over Lenoir. And so remember, feel free to pause this if you guys want to try it first, but you probably tried it for your workshop. So this is going to create a cis double bond. The double bond is going to be from carbon 2 and 3. So we're going to get an alkene. It's going to look like this. That's carbon 2, 3, and there's 1 and 4. And now we're going to react with Br2, right? And so what is this going to give us? Well, you guys know that Br2 adds 2 bromines, both carbons of the double bonds, so 1 on each, and that it adds with anti-stereochemistry, which means 1 wedged and 1 dashed. So let's just pick one of the carbons and draw a bromine. So let's say I pick this one, and then the other bromine here. Now we got to make 1 wedged and 1 dashed. So let's say I make this one wedged, the other one dashed. It doesn't matter which one you want it to do that way. So that's going to be our product. Now let's look at our answer choices. All right, so here's a problem. Look at the carbon chain on our compounds. It's drawn to look sort of trans in quotes. Remember, it's not really trans. There are no double bonds here, right? But you can see how we have these one methyl pointing up here, one down. In this case, this looks slightly cis, both methyls pointing upwards, right? So what this means is we're going to have to rotate a bond. Now you can pick any of these bonds, it doesn't matter. So let's say I'm just going to rotate the carbon right here. All right, I want to keep the other one the same. Or actually, let's do the other one. So it's going to look a little bit similar to, probably easier to visualize for our product that they're giving. So I'm going to keep the one in blue the same. So remember that this methyl is planar, it's pointing slightly upwards, and we have this wedged Br coming towards us slightly downwards, and because nothing else is written, we have an H that's dashed. All right. So you can see that we need to get this methyl right here to point downward. So let's redraw that this way, keeping this carbon the same. And so what is this now going to look like if we rotated the methyl to look planar, right? Well, if the Br was going to be wedged and coming towards us, it's now going to look dashed, right? Because this is going to be a full 180-degree turn, right? The methyl was up and planar, and now it's going to be down in planar. That's 180 degrees. The Br was coming towards us wedged. So if you want to take your pencil, right, take your pencil and say that the eraser is going to be the Br and angle it coming at you, right, on a slightly downward angle. Now rotate that 180 degrees. You see that the tip of that eraser is now pointing up and away from you. That means dashed. All right, so we get one of these to look, so they're both going to be dashed. Now we could rotate the one in blue, all right, and keep the one in red the same, and now we're going to have something that looks like this. Keep the one in red the same. And now we're going to have that Br wedged. So both of them, so our two products here are going to look at this. All right. Now this is in reality the same compound. You can just flip it, right, to give you the other one. And so we're going to get two products here. We're going to have, in our answer choice, it's going to be right here. It's going to be choice 1 and 4. Okay. Oh, now actually, let me just correct myself really quickly. These are not the same products, right? If you see, these are not like meso compounds or anything like that. So these are not the same product. Let me just correct myself. Okay. So we're going to get both choice 1 right here, both wedged, and 4, both dashed. Right. So again, just to reiterate, these are not the same product. You flip one of these, you will not get the other one. Okay. So now that we've covered that question, let's go on to another one. Now this is the roadmap question. Now once you see a roadmap, don't freak out, all right? It's not as bad as you guys think. And so they want us to draw compounds A, B, C, E, and F. So let me just write that A, B, C, E, F. So they didn't want all of them. So how do we approach this problem? Well, you're going to want to start from this alkane right here. And so you can see that the two reactions that lead to that alkane are H2PDC. So we know H2PDC works on both double bonds and triple bonds. So how do we know which is which? The hint is look at the reactions coming off of A and E. You've seen Hg2 plus H2SO4 over H2O. That's when we do oxymercuration on an alkyne. And you've also seen this. This is the hydroboration version of an alkyne, right? What this tells us is that A and E are triple bonds. But where are the triple bonds going to go? All right. So let's see. You see that Hg2 plus H2SO4 is going to give us a ketone because this works on the more substituted carbon of a double bond. So what I'll draw is, this is our alkane. There are only two possibilities of how we can have triple bonds on this carbon. The center, it's carbon 1, 2, 3, 4, 2, 3, 4. Or if it's on the end. One, 2, 3, 4. Now you could have put the triple bond on the other end. It's going to give you the same exact thing. So these are the only two possibilities of how we can have triple bond on this 4-carbon compound. Okay. So how do we again decide which is A and which is E? Well, let's look at the oxymercuration part. It's going to give us a ketone, right? Both and this reaction again works on the more substituted carbon of the double bond. So if we did the oxymercuration on this one, we can get the ketone on that carbon 2 or 3. They're the same, it's symmetrical. If we did it on this compound, we'd get it on carbon 3, right? So if we drew this, we'd get it on carbon 3. Here's 1, 2, 3, 4. 1, 2, 3, 4. Right? Both of these are ketones. So this doesn't help us narrowing it down. But E, this is the hydroboration, and it says we get an aldehyde. Okay? So that means that to get the aldehyde, well, this works on the least substituted carbon of your triple bond. This is not going to give us an aldehyde because both carbons 2 and 3 have other carbons coming off of them. But this triple bond right here, that can work on the carbon 4. So the hydroboration product, right, is going to look like this. Here's carbon 1, 2, 2, 3, and 4. We're going to get an aldehyde on carbon 4. So here's your double bond at O, the H. So what this is going to tell us is that this compound right here, that's going to be compound E, right there. And that means that compound A has to now be the other compound, right? We know that A is not going to be the terminal one because otherwise they would probably have written E here as well to tell you it's the same product. Or to tell you that, well, we know that it's not going to be the same. So we know that it's going to have to be the one in the center right here, right? Oh, I'm sorry, hold on. This is G. This is going to be G, the aldehyde. That means E is this aldehyde, or this triple bond over here. Let's bring that over there. So this is going to be compound E. Now, we know that the oxymercuration works on this compound, and it will give us a ketone. Now, the reason we know that this is not E as well, or this structure right here, is because they use a different letter to tell you that it's not the same compound. All right. So what A is going to be is it's going to be this one, this triple bond where it's in the center. So let's just move that down. So already we have A and we have E. So that's 2 down, 3 to go. So now we also need to find B. So B is going to work on A, and it's going to be NaNH3 liquid. Now we know what that does. That's going to give us a trans double bond. So we're going to draw compound A undergoing this. The triple bond is from 2 to 3, so our new double bond will be again from 2 to 3. And we're going to get this compound right here. That's going to be B. Now, what's going to be, they're also asking for C, and C is going to be HCl over H2O. Now we've seen this, HCl, the double bond is going to grab the H, kick out the Cl, and we're going to get a carbocation, and now the carbocation is equally substituted. Not going to matter which one you pick, and there aren't going to be any shifts. And now, because we have a solvent, and there's much more of the solvent than there is the HCl, this is going to come in and attack right there. You're going to get this compound, plus charge, and we're going to deprotonate this guy, and let's just draw what's probably going to be deprotonating it. It's probably going to be the water rather than Cl minus. Cl minus is very non-basic, so it's going to come in and attack that hydrogen, kicks that out, or brings that bond back, and we're going to get an OH. And so that is going to be compound C. So now we just need to get compound F, and compound F is going to be acting on, so to get compound F, we're going to do NaNH3 liquid on compound E. So let's go to E, NaNH3 liquid. Now this is going to give us the trans double bond, right? Similar to what we did on A to get to B. Now, the thing to watch out for here is the double bond is going to form from 3 to 4. So let's just draw that. 1, 2, 3, 4. There's your double bond. Now, again, there is nothing here that tells us if it's cis or trans because there are hydrogens, 2 hydrogens coming off of here, and we cannot assign priority to any one of those 2 hydrogens, which means that it doesn't matter if we use NaNH3 liquid or H2 Linoir. Remember, H2 Linoir gives us a cis double bond, but because there's no cis and trans here, it doesn't matter if you use H2 Linoir. And that was actually the question 9 on your workshop. Give an alternate reagent that will give compound F from E. All right? And so this is going to be compound F. And that's how you should approach this roadmap. So I hope this one helped clarify this question for you guys, and I will see you guys in the next video.